We want to draw lines using our parametric equations, and that's what we're going to look at in this video. Now, we have already seen that we can draw lines using the Bresenham's algorithm. In that algorithm, we have a starting position and an end position, and the algorithm will draw the line between those 2 points. Now, in our parametric equation of a line, we're going to have a starting point and a gradient, and we're also going to have the number of iterations, which in effect will give us the length of the line. So what we see here is the program actually running up just now, and it is drawing a line, and it's starting off at point 30, 30. So you can't quite see the center of the screen here. I haven't put the dot in this instance, but the center of the screen is roughly here. So we're going along 30, and we're going up 30, and we're starting to draw a line of gradient 3, and we're going to do that for 15 iterations. So let's zoom in just so we can have a little closer look at it. So you can see here the line started. So in this instance, what we're going to do, in effect, if it's a gradient of 3, we go along 1, up 3, along 1, up 3, and we continue doing that. Now you can see here that it's actually started off and it's gone up 2. Okay, so it takes a first stage to get started in the actual routine of drawing the line. So it goes up 2 here, and then it goes along 1. Now it's going to go up 3 here next, and it's going along 1. And again, it will go up another 3 along 1, 3 along 1, and it will continue doing that for 15 points. So we've got a little line from here to here, and we will have decided that by defining the start of the line and the gradient of the line and the number of iterations. So let's leave that, and we will allow that to run, and we can have a look at the code. So before we get on to the coding, let's quickly have a look at it in the graphical simulator. So we have the parametric equation for a line here, and it's x1 plus t1 and y1 plus mt1. So we can see how this works. The t is our parameter, and we can see we've got the t down here. In this case, t ranges from 0 to 5 in steps of 1. So you can see we've got 6 elements, so t goes 0, 1, 2, 3, 4, 5. And we put the t in here, so we can start off at a certain position. So the x and x1, y1 is the starting point. Okay, in this case here, the starting point for x1 is 0 and y1 is 0, so it just starts at the origin. So the first point is the origin, and the first value here, t is 0. So it's just going to be x1 plus 0 gives us the 0, y1 plus mt1 is just the y1 plus the m times the 0, again gives us the 0. So we've got this point here. Now we get the next point by adding on the parameter t. So we add on the value of the next parameter. So the next parameter, t parameter, is a value of 1. So you're going to have x1, which is 0, plus the 1. So we're going to go along 1. And then we're going to go up a certain value. So the value we're going to get up is going to be the value of 1 for t, but the gradient in this case here, m, is a value of 2. So we got up 2, so we go along 1 and up 2. And then we move on to the next value for the parameter, which is a value of 2. So we'll go along 2 and up 4, and so on and so forth. And we get each of these individual points. So you can see here that we're actually drawing a line using our parametric equations. Now, we could code this in exactly like this within our machine, but we would see the same problem occurring here. That is that we're not going to get all of the points in between. We're just going to get individual dots, and we're going to get a space between them. Now, it's okay whenever the gradient is going to be a value which is a fractional value, because when the gradient is a fractional value, then we're going to only ever drop down by a value which is less than 1 pixel. So it means that we can go along, and then we'll drop down 1 pixel, and we'll go along again and drop down 1 pixel, and along in 1 pixel. And we will continually do that. So it means that we will actually get something that looks like a nice straight line, and all of the points will be defined. But as soon as we've got the gradient, which is not a fractional gradient, that is, the gradient is greater than a value of 1, so for example 5, or it's less than -1, so for example -7, then we're not going to get this clean little line with all the points defined. We're going to get one point, and then it's going to come along and it's going to jump up to the next point, and it will go along and then again jump up to the next point. But because the gradient is larger than 1, we're going to miss all the other points in between. So all we're going to get is the dots, and we don't really want that. But there is a solution to it. And what we can do is, instead of, whenever we get a value for the gradient which is greater than the value of 1 or less than -1, then we can change the algorithm here slightly, or rather we can change the parametric equation. So whenever the gradient is a value of greater than 1, for example a value of 6, or less than -1, for example -7, then instead of going along the x-axis and then jumping up by the gradient, what we can do is we can go up the y-axis and then we can head along the x-axis by the gradient. So for example, if we wanted to get to this point here, rather than going along the 2 and then up the 4, we can go along the 4, up the 4 and over by the 2. So by doing this, it ensures that we can get to all of the points in between. So in effect, it's just like taking the steep line and making it shallow. And whenever we do that, we can then get all of the points in between. So the new value that we're going to use here is not this parametric equation, but this parametric equation. So it means that instead of having the y1 plus mt, you just have the y1 plus t. So we are just walking our way up the y-axis. But then whenever we get to the x-axis, jumping along the x-axis, we've got to jump along by the gradient. So and the gradient in this case here is going to be x1 plus the value 1 upon mt. Now the value has to be 1 upon m. And you can see why if you look, for example, at this point here. To get to this point here, we can go along 2 and up 4. Therefore the gradient is going to be 4 upon 2, which is a value of 2. But now we're not doing that. To get to this point here, we're going to go up 4 and along 2. So now the gradient is going to be 2 upon 4, which is a half. So the gradient of a half is going to be the reciprocal of the original gradient, which is a value of 2. So it's just going to be 1 upon 2. So for all values of m which are greater than or equal to 1 or less than or equal to -1, we're going to use this form here. So that's our little algorithm. Let's see how we can actually implement this in our assembly language. The calling function is on the right and the subroutine is on the left. We're going to push 4 values onto the stack. So we're going to have our x1 and our y1. So this is the starting position. We're going to have our gradient, which is m, and we're going to have the number of points that we want on the line. So I call this iteration because it's the number of iterations we work through the subroutine. And then we're going to jump to the subroutine fp underscore line. So that just stands for fixed point underscore line. So we jump then to the subroutine. It goes through the subroutine and it draws the line, and once it's finished drawing the line, it jumps back to this point here and it ends. So the values that we've put in the last example that we will see just in a moment are the value for x1, which is 30, y1 is 30, the gradient is 3, and the number of iterations is 15. So now we can change these to whatever values that we want, and they have to be in the standard for the fixed point arithmetic. So it has to be, for example, hash f and then the 0.0 at the end. But it doesn't need to be 0.0. We can put in any number at the end. So it could be, the gradient could be like 3.7 or 0.333 or minus 0.6, or whatever value, positive and negative, you want. So that's the calling function. Let's have a quick look at the subroutine. Now the subroutine is going to follow the little algorithm that we've seen earlier. So that's the algorithm there, okay. I'll make it a little bit smaller. So all we've got to do is in effect generate this algorithm within our assembly language, and that's what I have done here. So we're going to have in effect we're going to have the housekeeping up here. So I'll get rid of that just for a moment. We're going to have the housekeeping up here, and then we're going to pop off the values for return address, iteration, m, y1, and then x1. So we're popping them off and putting them into a little dedicated memory location within the RAM, which in effect are the local copies of the values from the calling function. We're then going to have to go through a test to find out whether the value for the gradient is going to be greater than 1 or less than -1, or if it isn't that, then it's going to be the fractional values. So we're just trying to check and find out what form of the iteration we're going to use. So if the gradient is fractional, we know we use one form of the parametric equation, and if the gradient is non-fractional, we use a different form for the parametric equation. So this here just goes through the test to find out which one it is, and then it jumps to the particular piece of code to run that particular function. So you can see here that from the algorithm here, we're going to have the value for the gradient is, if it's a fractional, we're going to do this algorithm here. So in this case here, this is actually called loop 1. So loop 1 here does all the way down to here, and that does the fractional values. Now if it doesn't jump to loop 1, then it's going to jump to a different loop. So in this case here, it's going to jump down to here. So it doesn't go straight into loop 2, it has to get into the division algorithm, because we know we're going to have to divide the value of the gradient from m to 1 upon m. So we generate the gradient 1 upon m here, and then we jump into this loop 2, and now the loop 2 here is going to go through this part of the algorithm. Now I'm not going to talk through all of the individual lines here because we've been through an awful lot of this code, and you can take your time and read through. I have a few notes at the right hand side here, and you can see what each of the lines is doing. Now there's nothing particularly amazing or different from this code here from previous code that we have generated over the last 4 or 5 videos. So it works through and it generates the each individual point. So whenever it's generated each of the points, you can see here I've taken a note here. For example, if we just go through this one, this part of the code here generates the x1 plus 1 upon mt, and the part of the code here converts from the decimal to integer, and then with this part of the code here plots the values off. Okay, and then we get to the bottom of the code and we finish off the housekeeping and then return to the calling function. And this is it returning to the calling function at this point here, and it heads over to the end, and that's the end of the code. So let's go ahead and we will see this actually running in our machine. So the program has finished here and it has now drawn the line out. So I will zoom in so we can have a little look. So you can see here that it's drawn a line. Now the position for the line is along 30 up 30 and it's a gradient of 3, and you can see here it's actually working through. So the first one, it's actually going up by 2, and then it's going along 1 and up by 3, along 1, up by 3, along 1, 3, along 1, 3, and it's along 1 and up 1. So you can see here this is actually giving us a line of gradient 3 starting at 30 30, and it does it for 15 individual points. So that's us able to draw really any line that we want on the screen. So that's the end of our section on parametric equations. I will do one short video just to show how we can get some other ideas for other parametric equations that we can generate, but we're not actually going to do them here in the course, but I'm going to throw them out there as a suggestion for yourself, and you can write these programs and you can test it out on the machine. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.